Okay, here we go. I need you to think back to the 3 instances that limits don't exist. The 3 instances where limits don't exist. 1.
There's a gas including the function.
Okay, so the right and the left-hand limits don't match up. What else? Okay, we are increasing or decreasing without bound. Ah, when we're oscillating. To where we can't tell. You remember that, like, when it looks like I scribbled on the board? Or you scribbled on your paper? Okay? Those are the 3 instances. Now, I foreshadowed a little bit, whether you caught on to it or not. When we have the instance where we decrease or increase without bound, yes, we're still under the impression that doesn't exist, but we can describe it now. Instead of writing does not exist, okay, in this case, we can write that the limit as x approaches 2 from the right goes to positive infinity because it increases without bound. And we can say that the limit as x approaches 2 from the left goes to negative infinity because it decreases without bound. I'll give you a moment to draw that and write that in your notes if you'd like. Okay. We now can describe the unbounded behavior by infinity or negative infinity. When is this going to happen? Like what's happening right here that's causing the unbounded behavior? The asymptote, okay? So what we're going to work on today is remembering how to identify an asymptote versus a whole, okay? And then, which is kind of what you did the other day with our discontinuities, right? And then we'll go through the analytical process that we need to take to determine, are we going towards infinity or are we going towards negative infinity? Okay. Now, if we can describe the limit as x approaches 2 from the right as positive infinity, and if we can describe the limit as x approaches 2 from the left as negative infinity, would there be a way to describe the limit as x approaches 2? Why, Lauren?
Because the asymptote's there. There's not going to be any x values there.
True. But remember, it's a limit, so we're going to approach it, right? So from the right, we're positive infinity. From the left, we're negative infinity.
So positive to 2.
Neutral infinity.
Well, you're talking about the domain. Yes, that would be the domain. But do those two match in their description?
No.
Infinity and negative infinity. No. So we would put it doesn't exist. Okay? Now, if they both went towards infinity, then we could describe the limit as x approaches 2 as infinity, if they both are unbounded in the same direction. Okay? Do you see where I'm getting at here? Okay? All right, so first of all, I want you to identify the asymptotes of these 3 functions. Okay? I'm going to give you about 3 minutes as a pod to identify the asymptotes of these functions, and you need to be able to defend yourself if I were to ask you why. Asymptotes. Vertical asymptotes.
It's a expression.
You just can't divide by 0, so. I got -2.
Because you built
What's the cosmetic denominator
Yeah.
I factored 2.
No, I was like, that it's like soggy. It could be
That's 1 over cos.
I'll be there.
No, I don't really just pick up a kick.
Okay, but you like slice it, so I guess they're
I don't.
Okay, whoever lives the closest is going to be your thank you for finishing my sentence, spokesperson. Okay, whoever lives the closest. Okay, all right. So, pod 8. Pod 8. What is the asymptote of h of x?
No trial would be x equals 1.
How do you know?
Because if you put 1 in for x, it'll make the denominator 0.
Okay, so pod 8 says x equals 1 because it makes the denominator 0. Pod 2, do you agree?
Yes.
Okay, thank you. Pod 5, j of x.
X equals -2.
Okay. Why is there only one? You said what? Negative.
And because if you factor out the denominator, then the x minus 2's cancel, so that's a whole, but there's still an x plus 2, which is where the asymptote.
Okay. Pod 4, do you agree that there's an asymptote at -2 and a whole at 2?
Yes.
Okay, thank you. Pod 6, g of x.
Yes.
X equals pi over 2, 3 pi over 2.
And Eli, how did you find those?
It's where cosine is equal to 0.
Okay, so secant is 1 over cosine. So cosine's in the denominator. Okay. Pod 1, do you remember how to write that as all of the answers?
Pi over 2.
Who's your spokesperson? Okay, excellent. Lady, yes. Yeah. So this is x plus 2 times x minus 2. So since the x minus 2's cancel out, there's a whole at 2. But since x plus 2 is left in the denominator, there's an asymptote at -2. Okay? All right, now, we haven't had to worry too much about asymptotes yet. You're going to have to be very careful with your limits. Okay? go ahead and write down, just write down this function.
Say
Just write down this function. Don't worry about what the top says. Okay? Is everything okay, Beth?
Yeah. Okay, that's just funny.
We're going to look at the limit as x approaches 1 from both sides. Okay? Now, what is happening at x equals 1? We have an asymptote. All right? If we use direct substitution, I would get -1 over 0, -1 over 0. And I have told you it's not okay to have a 0 in the denominator. And up until now, this would have been a does not exist. Do you agree?
Yes.
Okay. Now, if you have 0 over 0, I've told you that that means you can do something algebraically to work it out. But if you have a number over 0, that means there's an asymptote there. Okay? Now, what we can do is we can think about what our values are going to be as we approach that 0. Okay? So, plugging in numbers to the left of 1 would be like 1/2 and 3/4 and 7/8, right? If we plug in numbers to the left of 1, like 1/2, 3/4, what kind of numbers, positive or negative, do we have right here? Positive, like 1/2 minus 1 would give us a -1/2, right? Well, let's think of this. Let's just think about the denominator. Let me reword that, okay? Just the denominator, if we plug in numbers to the left of 1, we get negative, right? So we are approaching 0 from the negative side. So as we get closer to the -1 over 0, we have numbers that are -1 over negative really small, which means we are going to approach positive infinity. As we get closer to that 0, we do so with negative numbers. So we have -1 over negative numbers approaching infinity. Do you see what that thought process was? Okay, let's do it over here. 1 from the right side. Okay, direct substitution gave us -1 over 0. Okay, we know there's an asymptote there. We know there's some sort of unbounded behavior. If we plug in numbers to the right of 1, like 1 1/4, 1 1/2, okay, what kind of numbers will we get in the denominator as we get close to 0? Positive. So we, -1 over positive small numbers approaching 0, our fraction will go towards a negative infinity because we have -1 over positive numbers that are approaching 0. Okay, is that okay? Do you think so? Would maybe one more example be helpful? Write down this function. I know there's no such thing as a -0 or a +0, and if you don't like writing that, then don't. But it helps me think about what kind of numbers I have in that denominator. Okay? Sean, do we have an asymptote at x equals 1? Why? Because it makes our denominator 0, and there's nothing we can algebraically do to get rid of it. Would you agree? Okay. if we use direct substitution, we're getting 1 over 0 in both of these cases. When you get a number over 0, we have to consider that there's an asymptote there, and we need to figure out what the unbounded behavior is. Okay. I'll give you a minute if you're not done writing down. Okay. So the limit as x approaches 1 from the left. We know it's 1 over 0 by direct substitution. And especially since we're talking about one-sided limits, we know we can describe that some way. We are either approaching that asymptote towards infinity or negative infinity. Okay? So from the left, as I plug in numbers just a tad smaller than 1, what's happening in our denominator? What kind of numbers are we getting? Positive or negative? Positive. Wouldn't they? Because we're squaring them. After we square them, they would become positive. Okay? So 1 over numbers that are positive, that are slowly getting closer to 0. So we have 1 over really small numbers. That makes our entire fraction get bigger and bigger and bigger and bigger towards infinity. How about down here, as we plug in numbers to the right of 1, what's happening to our denominator? What kind of numbers? Also positive, okay? So we have 1 divided by numbers that are approaching 0, but on the positive side, once again, infinity, okay? So now what we could do is if I ask you for the limit as x approaches 1, since the right and the left side have the same description, we could describe the limit as x approaches 1 as infinity. Okay. First of all, are there any questions about any of, that was strange, any of those 5 limits up there? Turner.
So for the limit of f of x, you would say it doesn't exist because it's negative and positive.
That is an excellent question. Turner is asking for f of x, the limit as x approaches 1, would it be does not exist because we have negative and positive infinity? What would your answer be to his question? Yes, it would. Okay, thank you for asking that. Now, if I, like on your quiz Wednesday, were to give you, I don't know why did my toolbar come up? That's obnoxious. Okay. Sorry, I can't get it to scroll up on me right now. But if on a test I were to ask you this limit right here, since you know there is an asymptote, you would have to consider the left and the right to see if they both went in the same direction before you could answer this limit. Does that make sense? Okay. I'm sorry, I can't get it to go.
No, you're fine. I just didn't know if you circled the actual infinity, but I'm good.
Okay. Write this one down. Okay. How about I give you 30 seconds to discuss this at your pod about what you think the answer would be before we discuss it up here all together. Okay, 30 seconds.
The positive side.
I just know that asymptotes.
I get what you're saying, Marty, like, I didn't hear like 0 degree, 3 degrees.
Yeah.
I have like
2.
yeah.
So like the 2 over, like the 2 over, is that what you're saying? So if we do direct substitution, we get 2 over 0. So when you think about direct substitution, you have that 0 in your denominator,
But it's not just.
and it's an asymptote, then that's when you need to direct. Right, algebraic.
Like it's not being
Okay, pod 7 is having a discussion about how we know if this has an asymptote or not. Okay, do we have an asymptote at x equals 0?
Yes.
Okay, Dylan, why? Because the denominator equals 0. The numerator is not equal to 0. Okay, that would be a clue when we use direct substitution. If we get a number over 0, probably have an asymptote. Okay, 0 over 0, we probably can do something algebraic. Okay, also, is there any way to cancel out the sign of x? Okay, algebraically that would be your clue. Can we cancel out the sign of x? No, it's stuck there. Okay, so from the right side, when we plug in values just above 0, like pi over 4 and pi over 6, and those numbers just to the right of 0, what kind of outputs do we get? We get positive outputs.
Wait.
Hey, who said, hey, wait?
Wait, can you say
I'm just
that
trying to
again?
think. Can you say that again?
So she's.
Okay, so since we're going from the right of 0, if we imagine plugging in values to the right of 0, like pi over 4 and pi over 6 and pi over 12, when we put those into sign of x, our outputs are positive. So we're approaching 0 with positive values.
Okay.
So our fraction as a whole is going to approach positive infinity because we have positive over positive numbers. And we have a positive 2 divided by a positive really small number.
Yeah. So what about when it gets to pi? Like when you're typing in the asymptote?
Oh yeah, but I'm only concerned about 0.
Okay. Oh.
Yeah, I'm only concerned about the one at 0. Okay. All right. Do your best to draw these graphs.
No. I do. We're talking about. I didn't even. Yeah.
Yeah.
drawing this, I'm just gonna remind you that this lesson and then tomorrow's lesson are, the last two new material lessons for us. So Tuesday we will have a review for a Wednesday quiz. And then Thursday, Friday will be review for our Monday, Tuesday test.
And the other one,
Physics need all the tests on Wednesday, not Tuesday.
But good news, we have a 3-day weekend, so
Yeah.
that's exciting.
Best thing ever. Yeah. But it's supposed to rain when we
So we went to Patrick Day and started singing.
Yeah.
Oh, like when the lifeguards are in sweatshirts.
Yeah.
And you're swimming, that might be a sign that maybe.
Yeah.
That's the best time too, because no one else is there. And it's like, oh
My
my.
entire
Okay, raise your hand if you need a little bit more time to draw. Raise your hand if you need more time to draw. Okay, I will tell you, we are going to consider the limit as x approaches -1 from the left of f of x divided by g of x. Okay, -1 from the left of f of x. -1. -1 from the left of g of x.
0.
Is your answer going to be does not exist? It's not going to be. We can describe what is happening. Let's look at the graph. As we approach -1 from the left, we are approaching that y value of 0, but we're approaching it from underneath the x-axis. Do you agree? So our values are negative. We have -1 over negative values that are approaching 0. So we can describe that non-existent limit as we're approaching infinity. Well, let's just think about it. Okay? When we do the division, like if we were to combine these two, we would have an unbounded behavior. We don't see the unbounded behavior because they're two separate graphs. Here, I'm combining them. Okay? Now, remember when we talk about limits, we're talking about what are we approaching. Okay? So as this denominator approaches 0, our numbers get smaller and smaller and smaller and smaller and smaller. And if we take a number and we divide by itty bitty bitty tiny numbers, then our fraction as a whole is getting bigger and bigger and bigger and bigger and bigger, which is why we describe it as infinity. Does that make sense? I know this is like a weird concept to wrap your mind around, okay? Like I get that. Yes.
So only the values of the denominator, like, are what matter, like.
Well, this is just a solid -1,
Right.
right? We're approaching -1. That's not the issue. When we're approaching 0 and it's in the denominator, we have to think about, like, 1 divided by 0 is undefined, right? Which is why we know there's unbounded behavior there. Okay? We have to think about what kind of numbers are we coming from when we approach. Nicole, did you have a question? You sure? Okay.
But wouldn't it be, as we're approaching negative, like, you think about it.
Okay, so homework tonight, important. Okay, we gotta wrap our heads around what's going on with these unbounded behavior problems. Okay, like I said, tomorrow is the last time we'll take notes in Unit 1. We have a quiz next week, a test the week after. Alright?
Thank God.